Hello, everybody. Thank you for tuning in to another episode of the MP Sanders podcast. Now, I know I spend a lot of time talking about pharmacology and drug policy and things of that nature on this podcast, but my actual degree is Geoscience, and that's the field I currently work in, and my sort of 10-year goal is to be an environmental science professor. So I wanted to use my podcast as an opportunity to talk about environmental science and one of the most interesting periods in our planet's recent history, which is called the Younger Dryas, which ended the Pleistocene. So this is going to be the first episode in a series that talks exclusively about geoscience, and I'll have a whole playlist created for it, so it'll be separate from the other stuff, because it's not necessarily in the same idea range as talking about drug policy and free speech and political extremism and violence, but I still wanted to use my podcast as an opportunity to talk about these things. So let's go ahead and get started. So, the Younger Dryas is one of the most interesting climate changes in our planet's recent history, and by recent, I'm really talking probably about the last 150,000 years. There is no other ancient climate change in particular that has been as well studied or as controversial as the Younger Dryas, and I'm going to talk about what the actual climate change entailed, the potential causes for it, and then I'll go over some of the controversy surrounding it as well. To start, the Younger Dryas was the very end of what's called the Pleistocene, which was the climate epoch immediately preceding the one that we are currently in now, which is the Holocene. The Younger Dryas started around 12,800 years ago and ended 11,600 years ago, which 11,600 years ago is the mark of the beginning of the Holocene. And the Pleistocene was much different than the climate epoch we are currently in. It was extremely unstable. There were massive, severe, and abrupt climate changes happening relatively often and at a speed in which that we have never really experienced in the Holocene. The Pleistocene is also the home of the ice ages. There's this common misconception that there was a singular ice age during the Pleistocene, and it's a misconception. There were multiple periods of very high amounts of glaciers and ice sheets on the planet, and then there were deglaciated periods, some of them lasting as long or slightly longer than the amount of time we've been in the deglaciated Holocene. So this wasn't a simple stagnant climate epoch. It was constantly changing between glacial and deglacial periods, where sometimes ice caps were 2 miles thick in North America, and sometimes they'd fall back to levels pretty similar to what they are today. The Pleistocene itself started around 2.58 million years ago, and as I said, lasted until 11,600 years ago. Before the Pleistocene was a climate epoch called the Pliocene, and the Pliocene was sort of this transitionary period between a much warmer planet in the preceding epoch that led up to the Pleistocene. Because even though the Pleistocene was back and forth between glacial periods, it was still much colder than it had been, and each climate epoch that has been identified has its own unique properties. Like the Cambrian period had a huge explosion in biological life forms. The Pliocene was a slowly, steady cooling with some hiccups here and there, and then the Pleistocene was this very cold, dry, and unpredictable period of our planet's climate. And during the Pliocene, there was this massive expansion of grasslands and a remarkable amount of evolution and creation of different mammal species. Some of those species are like the woolly mammoths that become a big part of this conversation a little later on. So you can't really just extract the Pleistocene from the rest of Earth's climatological history. You have to look at what was leading up to this before you can really understand what was going on. And I just wanted to give a brief overview of the Pliocene. You have the expansion of grasslands, the evolution of mammal species, and a steady sort of cooling going into the Pleistocene, which led to the multiple ice ages taking place. So one example of the extreme instability of the Pleistocene are what's called Dansgaard-Oster events, and these events are marked by 5 to 15 degree temperature increases that took place in less than 25 years. They are usually followed by a much more steady cooling period afterward. We haven't had an established de-escalation in the Holocene. The only one that is potentially marked as this was the medieval warming period, followed by the Little Ice Age, which is the Little Ice Age is currently what we are coming out of now and what people are coining the Anthropocene. And human-caused climate change is something I'm going to discuss in another episode entirely. So today we're just focusing on this very specific event that happened 12,800 years ago. So just like when I was talking about the Pleistocene, I have to give a little bit of background to the Younger Dryas. So the Younger Dryas starts 12,800 years ago, as I've mentioned a couple times, but around 14,900 years ago, the most recent Dansgaard Oster event took place, and it's called the Balling Allerod. It was a quite significant warming period on the planet, and it caused a massive amount of glacier melting. But this warming was completely interrupted by the Younger Dryas, where temperatures dropped by about 12 degrees Fahrenheit in less than a century, and it stayed at these glacial ice age level temperatures for about 1,300 years. And by the end of the Younger Dryas, it warmed by about 18 degrees Fahrenheit, 10 degrees Celsius, in less than 30 years. So the Younger Dryas was marked by extreme sudden cooling, and then the ending was marked by extreme sudden warming. And at the end of that warming, the Holocene began. And the Holocene has been much more stable, much warmer, much more conducive for human life than the Pleistocene was. And that's one of the driving reasons that civilization really didn't start forming until after the Pleistocene ended. There are also some psychologists who have their own beliefs as to why it took so long for humans to really settle down and form a civilization. But if you just look at how the Earth was treating us, it is pretty clear that it would have been rather difficult to keep a civilization afloat when there were these extreme climate changes taking place relatively often. During the Younger Dryas, there were a series of mass extinctions, but really exclusively in the Americas and the Northern Hemisphere. The Younger Dryas is often depicted as some sort of global cataclysm, and that's just not really true. The Northern Hemisphere absolutely got punished with this severe climate change and temperature drop and then temperature increase, but that was really only exclusive to the Northern Hemisphere. And the reason for that will be discussed in a minute, but there is, like I said, just this idea that the entire planet was completely messed up and derailed during this event, and it's just not true. And people say that to push certain ideas like ancient civilizations and things like that, which is also something that's going to come up in this episode and in future episodes. But I just want to really nail down that this was mostly a Northern Hemisphere event. Now, there were mass extinctions in South America. The idea is probably that the climate change did impact these animals, and it drove a lot of humans into South America, and they probably played a decent role in driving these animals to extinction. But I will go into more detail about the animal extinction here in a minute. Aside from all of these animal species disappearing, there was also about a 65% decrease in the human population in North America. I don't know how many of you remember, but in middle school and high school, you probably heard about the Clovis culture, and one of the reasons they are commonly brought up is because of their sudden disappearance. And for a while, we couldn't really identify what happened to them, and it turns out that it was likely driven by this severe and abrupt climate change that I'm talking about in this episode. Another reason they're brought up is because they are, or were considered, the first people to actually come down and live in the Americas, and that's not true. That's certainly been overruled within the past probably 20 years, but if you've heard about the Clovis culture, it was for one of those two reasons. And I will probably also dedicate an episode to the peopling of the Americas. I know that's not necessarily geoscience, but it's hard to have conversations about these events in Earth's past without talking about the impacts they had on human populations and what human populations were doing during the time. And I think one of the reasons for that is when you start talking about just how violent these climate changes were, it's just a natural question to be like, what were humans going through during this time? You know, we've been around for 300,000 years as far as I'm aware. That's what the evidence shows. Modern humans like me and everyone listening to this. So we absolutely experienced these Dansgaard Oster events. We experienced the Balling Allerod. We experienced the Younger Dryas. And so I think it's a very fun and reasonable conversation to have about what exactly we were going through during those times. And I will dedicate another episode to that in the future. Now, from the beginning of the Balling Allerod and maybe a couple thousand years earlier to the end of the Younger Dryas, sea levels rose pretty dramatically. And it didn't happen as this sort of steady curve. Instead, it was a bunch of pulses in the meltwater, and some of them are the most famous one is Meltwater Pulse 1b because it was the largest and it happened at the end of the Younger Dryas with that massive warming spike. But there were three other big ones too, one taking place around 20,000 years ago, and then, of course, at the peak of the Bowling Allarod when all these glaciers were melting. So the Earth looks extremely different today than it did during the Pleistocene and during the Bowling Allarod and Younger Dryas. And this sea level rise likely plays a pretty significant role in why the Holocene is so much more stable than the Pleistocene. And even though the Holocene has been stable, it has had its oscillations. You know, the Minoan warming event saw temperatures in Europe 4 degrees higher than they are today in some areas. The medieval warming period saw Vikings farming in Greenland in areas that are now covered in permafrost. So just because it's been stable compared to the Pleistocene doesn't mean it's been a straight line in terms of average temperatures in certain areas. Now, that isn't to in any way try to discredit the current conversation taking place about climate change. It's just to say that this has not been a straight line. There have been warming and cooling events during the Holocene, and we're experiencing another warming event now. It's just that unfortunately we are contributing to this warming in a way that is not easily predictable. So it's kind of hard to predict the outcome of this because we haven't been able to establish with any certainty the amount that we have contributed to it, the amount that this sort of standard oscillation has contributed to it, and that is a worrisome thing, right? We shouldn't just say, oh, the medieval warming period had warmer temperatures in Greenland, therefore we don't need to worry about this. It's like, no, I mean, warming periods are generally good for humans, but it can get too hot. One of the most destructive extinction events in history was caused by overwarming, and it was the largest extinction event ever recorded on the planet. So there are limitations to this, and we need to make sure that we are contributing to this issue as little as possible without completely derailing our society. And again, just for comparison, we've seen about a 1.2 to 6 degree increase over the past 180 years. That's in Celsius. And if you compare that to what was taking place during the Pleistocene, like these Dansgaard-Oster events, 5 to 15 degrees in less than 25 years, that's Celsius as well, and then 10 degree increase in less than 30 years, you know, there's absolutely like levels to climate change, and some of them are extremely severe that can cause mass extinctions, and some of them can just make areas become more harsh than they should be. It can make plants hard to grow in some areas and also make it easier for plants to grow in other areas. Like 20% of semi-arid areas on the planet have seen an increase in plant growth since we started emitting CO2 into the atmosphere. So it's a give and take with anything that takes place when we're talking about how the climate reacts to things. Now, as I said about the sea level rise, one of the reasons that the Pleistocene was so unstable is partially as simple as the Beringia landmass being above water, because the Pacific Ocean was completely incapable of filtering out any temperature anomalies within the body of water, because it takes these cold water anomalies and pushes them further north into colder water, so it can keep filtering this semi-warm water throughout the Pacific circulation process. But during the Pleistocene, it was impossible for the Pacific Ocean to do this because the Bering Straits were above water, completely blocking off that access to the Arctic and very cold oceans up north. And it's pretty difficult to underestimate the role that ocean circulation plays in regulating our planet's temperature. And you'll see that more and more later on whenever I actually get into what caused the Younger Dryas. Right now I'm just trying to give a little bit of background information about the Pleistocene, the Bowling Allarod, and the Younger Dryas, because you really need to understand what was happening there before you can start talking about this specific event. Now, there's another mechanism for disrupting ocean circulation that was absolutely occurring during this time, and it may have played a role, well, it certainly played a role in the instability of the Pleistocene, but it may have played a huge role. And it was just that these glaciers would grow to be far too big and then collapse under their own weight, dumping a ton of fresh, freezing water into the Atlantic and Pacific Ocean, disrupting this whole circulation that regulates our planet's temperature. There's another proposed mechanism for the instability of the climate change, and of the Pleistocene, and I'm not as convinced of it, and it's talking about Milankovitch cycles. And the Milankovitch cycle depicts the changes in the Earth's orbit around the sun, because it kind of ebbs and flows. Sometimes it's a little more ecliptic, so you get further away from the sun in certain areas, and it just causes these gradual changes in the planet's climate. Now, the reason I'm not so convinced about the Milankovitch cycle playing a major role in the instability of the Pleistocene is because of how gradual the process with that cycle is. These climate changes were happening in less than 30 years, as I mentioned, and there's just not enough energy in the Milankovitch cycle to explain this. What the Milankovitch cycle does explain is how the Pleistocene started in the first place. So it's sort of this overarching cause of what was going on, but not able to explain these specific events that I'm talking about here. And one of the reasons these glaciers collapsing could cause these sudden and extreme warming events is because of how much CO2 and other greenhouse gases they trap. When they suddenly collapse and they dump all of this into the atmosphere, you're going to get a warmed planet, right? That's sort of the whole debate that's taking place right now. But there is a caveat to that, and it is about the Younger Dryas. The Younger Dryas contained way more CO2 than the youngest or oldest Dryas, but it was colder than both of them. So it's not a determining factor for temperature, but it would have been much colder if that CO2 levels would not have risen. So, what exactly caused this severe cooling period called the Younger Dryas 12,800 years ago? Well, it's simple and it isn't, and I've kind of talked about it a little bit, and it's that the ocean circulation, particularly in the Atlantic Ocean, was disrupted by the collapse of the North American ice sheets. And what this does in particular is it keeps all of the cold water in the northern hemisphere and keeps all of the warm water in the southern hemisphere, which is exactly what you see when you look at these sort of isotope graphs about temperature and humidity. The southern hemisphere, particularly water around Antarctica, was steadily getting warmer until the Holocene started, where Greenland had that incredible spasm of cooling and then that incredible spasm of warming. And it's because of this disrupted ocean cycle. Where it isn't simple is what exactly caused these ice sheets to collapse. So, for a little bit of background here, for a while, really before carbon dating became really popular in geoscience and ancient climatology, we assumed that these cycles from going from glaciated to deglaciated periods were very slow, taking 50, 30,000 years, And the math that you calculate determining the energy that was being given from the sun supports that. If it was just the sun causing this issue, it would have taken 30 to 50,000 years for these ice sheets to melt and dump into the ocean. And the reason for that is pretty simple, right? Like in the winter, there wouldn't be much melting going on. So it's not, you really have to cut that in half, right? So you have this in the summer where it's warmer than normal and the sun is putting all this energy on the ice, it melts and then it refreezes and then it melts and slowly you run out of ice and you disrupt ocean cycles. But as you've seen in the couple graphs I've pulled up, the warming took place, well, the spasm of warming took place in less than 30 years, but if you're really looking at from the beginning of the Bowling Alley Rod to the end of the Pleistocene, you're talking about 3,000 years max. So there needs to be an explanation about what exactly happened here, because it was actually referred to as sort of an energy paradox back whenever we first discovered this, because geoscientists were like, well, damn, this happened so much faster than we thought it did, and we don't really have an explanation for how this could have collapsed in this way. And there are two main hypotheses right now. One of them is slowly gaining a little bit more traction, and the other one has kind of been in place for about 30, 40 years. And I think there is a possibility that they are both true, which is what I'm going to talk about in a minute. But right now, the main idea is that these enormous glacial lakes were forming during the Bowling Alley Rod as the ice was melting and the planet was warming rather quickly. And these glacial lakes were massive. Lake Agassiz is as far as I know, the biggest one that we know of, and it had more water volume than the entire Caspian Sea. And slowly this water kept building, and then the weight caused the ice dams that were holding them in place to break, and then all of this water would come flooding out into the Atlantic Ocean, disrupting that ocean cycle. So the more, as far as I can tell, accepted hypothesis for what happened here with the Younger Dryas was that these enormous lakes formed. They were being dammed in by the glaciers, and then the glacier walls broke under their pressure. And there's a lot of evidence that this was occurring. I don't think it's really possible to deny this, because you have what's called subglacial flooding, where the immense pressure from these massive lakes were putting a lot of pressure on the bottom of the glaciers, and the bottom of the glaciers would break and give, and then all this water would go beneath the glaciers and tear up all the ground beneath them. So it's a perfectly reasonable, sort of gradualistic explanation for what took place. And when you talk about the warming that was taking place in the Bowling Alley rod, it's perfectly feasible that this was the cause. But there are still a couple problems that another hypothesis tries to address, and one of them is that it's been pretty hard to establish how these lakes formed so quickly in the first place, because even though it was warming, that doesn't necessarily mean there was enough energy to form literal seas behind glacier walls. So that's a problem, but it's not a problem that completely dismisses the idea. It may just be that we haven't done the calculations properly. Maybe the Bowling Alley rod was a little bit warmer in some areas than we currently think, or, there could be a bunch of explanations as to how these lakes formed, still fitting within this overall hypothesis. Now, the next explanation that has gained a lot of traction in the last 13 years, really, is a little more controversial, and it's one of the reasons why I said this climate change is controversial to begin with. It's mainly because of this Younger Dryas impact hypothesis. And the idea is that there were a series of comet impacts, mainly focused in North America on the ice caps that pulverized the ice caps. And this would give an explanation for the really rapid breakdown of these glaciers and ice caps. And the first paper published on this topic was in the Proceedings National Academy of Sciences in 2007 by Firestone, and it's up here on the screen, titled Evidence for an Extraterrestrial Impact 12,900 Years Ago That Contributed to the Megafaunal Extinctions in the Younger Dryas Cooling. It's been very interesting watching this idea evolve, because it has been hit really hard a couple times, and then somehow it always manages to bounce back with more evidence. But it's still far from established, and one of the primary reasons is that there has not been a crater found dated to this time. But that doesn't necessarily mean we need to dismiss the hypothesis altogether. So first I want to actually line out what the hypothesis is. It's not that there was a singular impact. It's that there was a sort of bombardment over the course of a few centuries or maybe even 1,000 years. And while that may seem implausible, there's something that you need to consider, and it's that Earth passes through something called the Taurid meteor stream twice a year. And it was formed by an enormous comet around 100 kilometers wide, coming into the inner solar system and disintegrating due to Sun's gravity. Jupiter's gravity probably disturbed it on its way in, and now we pass through the debris field left behind twice a year. And some parts of this debris field are extremely dense, with some pretty large cometary fragments within it. And the idea is that during this period, we were passing through a particularly dense part of the Taurid meteor stream, and you had dozens, if not hundreds, of impacts and airbursts over the course of a few centuries. Now, I know I said that there has not been a crater found, so the obvious next question is, well, why would we suppose there was a comet impact at all if we don't have a crater? And you have to understand what happens to the Earth's crust when there are airbursts or cometary impacts. And one of the things is that it forms immense pressure and temperature that's not even possible in volcanoes on the planet, and it leaves behind these very specific substances. They're called impact proxies. These are carbon spherules, which are very, very small ball-bearing shaped type objects made of carbon. And you have nanodiamonds from the carbon being put under that immense pressure and temperature. And you have this melt glass that's from literally melting the silicate of the Earth from the temperature and impacts. And it is absolutely true that dozens of studies have found clusters of these substances in and around the Younger Dryas, indicating that something took place that produced a lot of pressure and a lot of temperature in multiple places around the planet, which is where the fragmentary sort of going through the meteor stream comes in, because there have been impact proxies dated to this era found as far east as Syria, as far south as northern South America, and as far north as Greenland. Right? So this was sort of a entire northern to central equatorial hemisphere situation where these cometary fragments were impacting. But if they were mainly focused around the North American ice caps, not only would that explain the rapid breakdown of these ice caps, but it would also sort of explain why we haven't found a crater. If it impacts on ice and the ice is gone by the end of it, it's not going to leave much of a mark on the Earth's crust. Now, there's another line of evidence for this as well, and it's called the black mat layer. This is mostly pronounced in Murray Springs, Arizona, but there have been black mat layers dated to this era, again, found in Belgium as well. And this indicates a very specific thing that took place, and it's that there were massive wildfires around this time. So if we look at the Chicxulub impact, for example, which is the one that killed the dinosaurs, you see these impact proxies. You also see an enormous crater in the Yucatan Peninsula, which is what actually led to the hypothesis being accepted in the first place. But you also see black mat layers all over the Western Hemisphere because whenever this massive object came crashing into the planet's crust, it sent superheated ejecta, so big pieces of the comet, or asteroid. It was an asteroid with a dinosaur. You get big fragments of this asteroid and big fragments of the crust that are thousands of degrees, and then it lands in a forest, catches everything on fire, and these fires just spread everywhere. So these two images, the one on the left is Murray Springs, and the one on the right is a black mat layer associated with the Chicxulub impact. You can see that there is a clear similarity here, and it's because there were massive wildfires during the Younger Dryas. In fact, some studies have been published that say up to 10% of all the biomass on the planet was burned to soot during these fires. That is a massive amount of land. I saw a study, I've had a really hard time finding it recently that isn't behind a paywall, and I don't necessarily want to cite it if I can't show you the specific sentence I'm talking about, but I read a study, I want to say it was 2-3 years ago, that said up to 85% of Montana in particular was soot by the end of the wildfires. So this wasn't a minor situation. It explains these animal extinctions, it explains the impact proxies, it explains the drop in human population, but there are issues with the hypothesis. Of course, the crater being one, but two, these impact proxies are not necessarily clustered around the Younger Dryas onset. Some of them are found a couple thousand years before, like during the Bawling Alarod. Some of them are found dating into the Holocene. Now, that doesn't necessarily mean it didn't cause it, but it certainly wasn't a singular event, which isn't necessarily an issue. You know, there's comet impacts and airbursts all the time. Thousands of them a day occur. But the most recent major one that came out of the Taurid meteor stream was Tunguska in the early 1900s. It flattened square kilometers of forest and started some wildfires in the area. There's a picture of its damage here. Now, one of the other issues with this hypothesis is that there is also a platinum anomaly around this time. And platinum is not associated with comets, it's associated with meteorites. So the Comet Research Group is the team of scientists that has published the majority of the papers on this topic. I haven't really seen them be able to connect those issues. Why is there a platinum anomaly if this was a cometary strike? Now, you could say that the comet had some asteroids buried within it, which I'm sure they have said. That'd be like the first sort of logical explanation for that happening. But it's still an issue that I haven't really seen addressed. And if I'm missing a paper that got published, please link it in the comments or whatever you need to do, because I would love to know if they've been able to bridge this gap. Those things are just to say that the impact hypothesis is far from established, and it will take a bit more debate and discourse in the scientific community to really iron out what happened here. Now, earlier I said that both could be possible, and all I mean by that is the Atlantic Ocean circulation would have still been disrupted if the comet impact or series of impacts is what occurred, and it also just fills some of these holes of how we're not really able to explain the rapid breakdown or how these lakes formed rather quickly, so there's still a lot of debate to take place with this, but right now those are the two main hypotheses as to what caused the Younger Dryas. Now, there's a third that I don't hold with much value, but I would still feel kind of weird if I didn't bring it up, and that is the hypothesis that Robert Schoch has put forth. He's a University of Boston geologist. He was a pretty reputable geologist for a while, and then he went really, really deep into this lost civilization of the Ice Age idea, and I want to be clear about something here. Graham Hancock is sort of a special person in my heart. The conversations I've heard with him and Randall Carlson are one of the main reasons that I decided to enroll in a geoscience program to begin with. Now, unfortunately for Graham, the more I learned about the history of our climate and the history of how humans have interacted with our climate, the less I've become convinced of his ideas. So I want to make that clear, but there are still some things about Robert Schoch in particular that I still find convincing, such as his dating of the Sphinx. And I will talk about that on another episode. But just because the Sphinx may be older than the accepted date. I fucking hate phrases like that. But just because it may be a little bit older than we expect it to be, that in no way is evidence of an advanced civilization in the Ice Age. We have Göbekli Tepe and Gunung Padang, which Gunung Padang is very controversial, and again, I'll address all this in another episode, but again, we have large, intricate structures from the time that Robert Schoch has dated the Sphinx, which is about 13,000 years ago. So it's not impossible, and he has pretty high quality evidence, in my opinion. But again, to go from carving a lion out of bedrock to saying advanced seafaring, potentially metallurgic civilization is a leap I'm not willing to make anymore, basically. So his idea is that a coronal mass ejection caused the Younger Dryas. And these are basically huge radiation and energy bursts from the sun. And his evidence for it is weak, but it revolves around two main things. One, that is absolutely true, that there was a huge growth in the amount of people moving into caves for their main sort of living. And the reason they would have done that is because there is one cause of these impact proxies that I didn't mention earlier because I didn't want to talk about it until now. And that cause is lightning. Lightning causes these things in very, very small amounts in certain circumstances. Now, if there was an enormous electromagnetic storm on Earth, there would literally be lightning bolts that are huge. Not these skinny things we see in thunderstorms, but there's been some sort of physics evidence that lightning could be expanded to a couple 100 feet wide if the circumstances were correct. And that's sort of the idea that he's proposing here. He's like, oh, well, the reason you see all these substances all over the Earth is because there was this insane electromagnetic storm that caused these absurd lightning storms that we have never really experienced outside of this. And there's another piece of evidence he has that is, well, actually, everyone should know about this, particularly if you live in America, because when CMEs happen, it changes the way aurora borealis work on the planet. Just a few months ago, it may have been a year ago now, it's been a while, but the auroras were visible as far south as Arkansas because of a pretty strong CME. Now, the auroras he's hypothesizing here as a result of this CME weren't like faint ones you could kind of see with your phone camera, which is what we got here in Arkansas, but very intense, visible, and long-lasting auroras all over the planet. And his evidence for these things occurring is that, one, he's been able to recreate a similar situation in the lab and create what the auroras would have looked like, and perhaps it's coincidence, perhaps it's not, but there are a lot of cave drawings depicting a very, strikingly similar shape, and they're all being painted that they existed in the sky. So that is where he bases his CME argument. I'm not really convinced by it because we have no evidence that a massive CME, particularly of that level, occurred during that time. So just like we can determine temperatures and sort of wet and dryness, not necessarily humidity, but wet and dryness on the planet using oxygen and various other isotopes, we can also do something very similar with CMEs. We can look at isotopic concentrations and determine whether or not there were large electromagnetic storms, and it just wasn't happening during the beginning of the Younger Dryas. It just wasn't, according to the geologic record. So I like Robert Schoch. I think he is a brilliant geologist. Some of his papers are almost impossible to read because they're so technical in geology. But I think I don't want to say he's gone down the wrong path. That sounds judgmental and kind of stupid, but he's just gone down this very, very specific path of talking about ancient civilizations, talking about a CME that probably didn't happen, and the view of a lot of other academics, his credibility is sort of brought into question over that. But as a geologist, I respect him. I think he has done tremendous work in that field. But when it comes to this particular topic, I don't find his hypothesis convincing. Now I've got two final things to say, and I just want to talk a little bit about the Graham Hancock, Robert Schoch, John Anthony West characters for a second. There is a huge sort of pushback and denial, and I'm not going to say hatred towards Graham and those people from the academic community, particularly among archaeologists and even some geoscientists, and I don't share that feeling towards them. I think that they're probably wrong about 75 to 80% of what they say, but I don't recognize them as being harmful entities in this field. If you can inspire thousands of people to investigate something as dry and boring and technical as ancient climatology, then you're doing something right. Now, that isn't to say that it can't be sort of like misleading and maybe lead to some harmful forms of misinformation and uneducation taking place. But again, if you're a real sort of objective researcher that's looking into this, I don't think it's possible to be very convinced by their arguments after you've looked into it a lot, which is, unfortunate for them because, like I said, they did kind of play an inspirational role in me becoming a geoscientist. And again, as I've gone further into that, the less I agree with Graham's hypothesis. And again, there will be multiple episodes, I think, dedicated to that. And I think one of the ideas I have is I'm going to have a series where I go through the Joe Rogan episodes with Graham and just sort of specifically analyze all the big claims he makes and go from there. And maybe I'll sort of deconstruct his TV show as well. But I think Graham, he seems like a pretty good person. He's funny to me in a weird way, and I think he, in an overall sense, has done a good thing for archaeology and geology, solely because of the amount of people that have become inspired to investigate it because of his work. Even if he's wrong, like you can talk about thousands of, maybe that's probably an exaggeration, you can talk about a few big physicists and big scientists that inspired a ton of people that ended up being wrong about something. Newtonian mechanics aren't necessarily accepted when compared to general relativity. But Newton probably played a role in a lot of people studying physics. And just because he was wrong about some things doesn't mean that he was dangerous to physics. So I want to make that pretty clear, but I also want to make clear that one of the most annoying things about Graham is his persecution complex. It's hard to listen to him sometimes because of how much he's convinced himself that the reason his ideas aren't accepted is due to persecution and not just being incorrect. So I'll leave it there with Graham and move on to the next point, and that is the megafaunal extinctions of this time frame. So just like everything else associated with the Younger Dryas, there is some controversy around this. There's some debate, and there's also some misunderstandings, which I'm going to try to line out here. So whenever we started finding this extinction event in the fossil record, we had a specific idea as to what caused it, and it was that humans overhunted these animals until they went extinct. And there are a few reasons for that are absolutely reasonable. There's a lot of people who I criticize the hell out of that idea, and I'm about to in a minute, but there's a lot of people who criticize it that don't give the devil its due, so to speak, and I want to do that real quick. So first, that absolutely happened in Australia. It started a little bit before the Younger Dryas. It seemed to start around 30,000 years ago, and they drove a ton of animals extinct on that continent. And then you have the issue, or the idea, that the first humans that came into the Americas came in around 15,000 years ago, and these extinctions started taking place pretty shortly after that. And then the most convincing issue, or like if I didn't know the things I'm about to talk about, would be that these animals had never once in their evolutionary period ever encountered anything like a human. We came out of Africa, and the eastern hemisphere is where we evolved alongside other animals over the course of millions of years. Not just hundreds of thousands with modern humans, but other ape-like beings that were evolving with these deer and with these lions and with these other animals, so they learned how to co-evolve and coexist with us in a way that we weren't necessarily even able to hunt them all to extinction because they learned how to deal with us. When you look at the Americas, that did not take place at all. So when these people came down, there was this huge thing, it's called prey naivety, and it means that they just didn't know what we were and didn't know how to deal with us. And you see this sort of knowledge that animals gain in areas where hunting's very popular. So if you go to Wyoming, I used to live in Wyoming on an elk hunting ranch, and on the ranch, which was 200,000+ acres, it was fucking massive, it was difficult to see an elk. They'd come down at certain parts of the day where they knew you couldn't shoot them. So at night, like 2 a.m, I'd wake up to elk screaming by my house because we couldn't hunt them at that time. But if you go up to Yellowstone, if you go around the property, like stomping through the woods in areas and times where the hunting guides would take people to go hunt, they were very difficult to locate and find because they knew, like, this time of the day in this area, there's going to be people trying to kill me, and they would avoid it and hide, whatever. But if you go up to Yellowstone where there's no hunting allowed, these animals will let you get within 100 feet of them without batting an eye. So animals learn these things. And when they're completely naive, and in a sense we are recording that at Yellowstone, like they are naive to a hunting human in that area of Wyoming and Montana. If you suddenly introduced hunters to that area, that population would not respond well to it. And you could probably drive elk extinct in Yellowstone if you wanted to. Right? So that was sort of the motivating factor behind saying humans caused this mass extinction at the end of the Pleistocene. And the technical name for the extinction is the late Quaternary extinction or the terminal Pleistocene extinction. That's what I'm referring to. And so let's go over some of the information about just how severe this extinction was. So in North America, more than 70 species of megafaunal animals went extinct. And what that means is any animal that weighs more than 44 kilograms or around 100 pounds. There was a similar number in South America and even more in South America. There were also, the numbers really kind of fluctuate with the birds, but the most consistent number I've seen is that around 19 different bird genera went extinct as well. So this was a massive event in the Western Hemisphere. And there were also some mass extinctions in Europe at the time, which again would make sense in the Northern Hemisphere. And as far as I can tell, the idea of overhunting, particularly in the European extinction, has been all but abandoned because it just doesn't line up with anything anymore. But in the Americas, the animals that were going extinct were saber-toothed tigers, the American lion, the American horses, giant ground sloths, the short-faced bear, armadillos the size of like small cows. All of these animals went extinct, and it was the idea that we drove them to extinction mainly because of another animal that went away at that time, the woolly mammoth, and the other mammoth subspecies. Because there were dozens of hunting sites for mammoths, of us chasing them off of cliffs, of us killing them with bows and spears and what have you. So there were hunting sites. We thought that we came here at this particular time period. We thought these animals were naive to humans, so there was a lot sort of lining up for humans driving this extinction. But that has changed quite a bit, and for quite a few reasons. The first one being, it is absolutely no longer debatable that humans have been in the Americas for a minimum of 25,000 years. There is some evidence that pushes it back to over 100,000 years. Now that is much more debated, and I'm talking specifically about the Cerruti Mastodon site, which supposedly shows a mammoth skeleton with the bone marrow extracted with hand tools nearby. Now to be clear, the hand tools are rocks that are kind of sharp, that were supposedly used by Neanderthals or some other similar human species that carved these animals up. Again, that one is hotly debated, and I'm not going to stake any sort of validity on it at this point. But it is undeniable that humans were in Mexico 25,000 years ago. And the way we confirm this is finding footprints dated to that time of an animal that could have been nothing other than a modern human. So that's sort of the first strike at this idea. If we were here for 25,000 years, why did it take 10,000 years for the animal naivety to kick in and for the extinction to kick in? One of the other things that is a really huge problem with the overhunting hypothesis is that there were probably more mammoths on the planet than humans at this time. Why would we hunt that to extinction, right? A singular mammoth could feed a large tribe of people for months. We're not going to continue hunting them when we don't need them. Not only do hunter-gathering tribes not tend to do that, but it's also the fact that there were more of them than us. So us driving them to extinction alone is pretty much impossible. Now, another one of the major issues with this hypothesis is that there have been 0 confirmed kill sites of many of the animals that went extinct. So we don't have evidence that we even hunted the majority of the animals that went extinct at this time. So if you're going to say that humans drove the extinction, you better be able to find hunting sites for these animals that are now extinct. And we can't do that for most of them. And as our understanding of these things that I just lined out progressed, it led to a point where less than 10% of archaeologists think humans were the driving cause. The driving cause of this extinction event was the climate changes that took place during the Younger Dryas. Right? If you are operating off the idea that this climate change took 50,000 years rather than 3,000 years, then sure, you can sort of have this human-caused extinction. But when you see these incredible temperature oscillations taking place in a really, really short period of time, and you're seeing massive wildfires all over the Western Hemisphere, and you're seeing massive human population drops, which is another thing. If our population's plummeting, who the hell thinks that we could hunt saber-toothed tigers to extinction, right? That's just not possible or plausible, right? So it is no longer accepted, as far as I can tell, by anyone in the field of archaeology, and even most evolutionary biologists have abandoned the idea as well. But I want to make something clear. If we are talking about human-driven extinction in ancient times, the authority on the topic are the archaeologists, or the ancient sociologists, right? The people who actually studied human behavior and human society and human migration during that time period. Because we're talking about humans, so the scientists studying humans need to be the ones we listen to first, right? And then you can throw on this climate change stuff, and then you can sort of talk about the fact that maybe climate change wiped out 85-90% of these animals, and we finished them off because we were also starving and going through something of a cataclysm ourselves. I think I'm going to wrap the episode up there, and I hope you guys enjoyed this and learned something. This is one of the most interesting periods of our planet's history, period. Like, it is just as interesting as the Triassic period, in my opinion. Just a short, like, 3,000 year period. So much shit happened on this planet that it's sort of hard to conceptualize to us because of how stable our climate epoch has been. So I hope you guys enjoyed the episode, and I think the next episode I release will be my first addressing of the Graham Hancock style claims. So thank you again. I know this was kind of a long episode, and whenever I'm doing the Geoscience series, this length is probably going to be the standard, just because it is my actual area of expertise, and I love the topic, and there's so much to talk about with it. So enjoy, and I'll see you guys soon. Thank you very much.